Hello grade 11s. In our last lesson on measurement, we will be converting between degrees Celsius and degrees Fahrenheit. In our last lesson, I told you that degrees Celsius is our metric measurement and degrees Fahrenheit is our imperial measurement. Okay, now let's have a look at the two formulas that we can use for converting. Okay, so the first one is to go from Celsius to Fahrenheit, and it is 5/9 multiplied by the degrees in Fahrenheit minus 32 degrees. Okay, if you want to go from Fahrenheit to Celsius, you're going to go degrees Fahrenheit is 9/5 times your degrees in Celsius, and then that is going to be plus 32 degrees. Okay, so those are our two formulas for converting, and you will always be given one of them. And you may be given this one when you have to find the degrees Fahrenheit, which means we'll be solving an equation. So you could be given either of these. Okay, let's have a look at a couple of examples. So for our first example, room temperature is often used in calculations as 27 degrees Celsius. Okay, so when we talk about room temperature, perhaps temperature that red wine should be kept at, we say that it is 27 degrees Celsius. Now, what is the temperature in Fahrenheit? And they are telling us in this question to use this formula over here. Remember that you will, in a question, be given the actual formula. Okay, so that's the one that we're going to be using. So our degrees Fahrenheit, we always first start by writing out the formula times our centigrade times our Celsius plus 32 degrees. Okay, so now we're going to say degrees Fahrenheit is 9/5, and we are going to substitute our 27 degrees in there plus 32. And we can do this whole calculation in one step on our calculator. Okay, so it's going to be 9. We need our fraction button. Remember, on this calculator, if you press 9 and then your fraction button, it automatically takes you to your denominator, which makes it quite easy. And then we're going to multiply that by 27, and we're going to add 32. Okay, let's see what we get. We're going to get 81,6. I've made a mistake there. Have a look there. That's supposed to be at 32 degrees. Okay, so it gives us 80,6 degrees. Okay, so this is 80,6 degrees, and this is now degrees Fahrenheit. Okay, now let's have a look at the second example. There is a book called Fahrenheit 451. And this title, okay, that's the title of the book. It refers to the temperature at which book paper burns. Okay, in other words, the paper that books are made of. That's the temperature at which book paper burns at. Okay, what is the temperature in degrees Celsius? Okay, and we want that to the nearest whole degree. Always check. Remember, in the front of your paper, it will tell you to do it. Usually correct at 2 decimal places unless otherwise specified. And here we're saying to the nearest whole degree. Okay, and the formula that they want us to use is this one. The degree Celsius is 5/9 degrees Fahrenheit minus 32 degrees. Okay, so we're going to substitute in. So degrees Celsius is going to be 5/9 degrees Fahrenheit, which is 451 as per the title, minus 32 degrees. Okay, so again, we're going to do this in the calculator, and we're going to do it in one step. Okay, so our fraction again, so it's 5/9 times, we're going to put in a bracket now. Made a mistake, go sideways first, then times, open bracket, 451 minus 32, close your bracket, and let's see what that gives us. Okay, 232,77. Okay, so 232,77 recurring. and they told us to go and round this off to the nearest whole degree. Okay, so in other words, we're rounding off to this position over here. So we look at this one. This 7 says take that one and make it one higher. So our final answer is going to be 233 degrees Celsius. Okay, now let's have a look at two examples where you have given the wrong formula, if I can put it that way, where you're going to have to actually solve the equation. Okay, now the temperature on the moon is approximately negative 378 degrees during their nighttime temperature. Okay, now convert this temperature to degrees Celsius, and we want to do this correct to 2 decimal places. Okay, so what Celsius and to 2 decimal places. And they're now telling us use the formula. Degrees Fahrenheit is 9/5 times your degrees Celsius plus 32 degrees. Okay, so we're still going to do the same thing as what we did previously. We are going to be substituting this in. The thing is that we have to put it in here because it is our degrees Fahrenheit. So here we're going to start with negative 378 degrees Fahrenheit. Okay, equals 9/5 times our Celsius plus 32 degrees. Okay, so now we're solving an equation here. So the first thing we have to do is we have to take this plus 32 onto the left-hand side. And to do that, we have to subtract 32 degrees. So on this side, you're going to get negative 378. And we're going to subtract 32 degrees. And that gives us our 9/5 times our degrees Celsius. Okay, so now we simplify the left-hand side, and that is going to be negative 410 degrees is 9/5 times our degrees Celsius. Okay, now how do we get rid of this fraction? Well, we could divide the fraction by 9/5, or we could just multiply by the inverse. So we could multiply by 5/9. And whatever you do on the right, you have to do on the left as well. Okay, so in other words, our final answer here, so it's bloody dogs that keep barking. Okay, so here this cancels and we get 1, which is what we wanted. So our degrees Celsius, and on this side we have to multiply these two. So let's do that. So it's going to be 5/9 times, open our bracket, or you don't really have to use a bracket, but we can, 410, close your bracket, and that gives us an answer of negative 227,7 recurring. Okay, so negative 227,7 recurring. So now we set to correct to 2 decimal places, so it's going to be negative 227,78 degrees Celsius is our final answer. Okay, let's look at one more example. Okay, a general rule of thumb, which is in other words, a rule that we can generally use, that is used by pilot, is that for every 1,000 feet of altitude, in other words, every 1,000 feet that they go up, the temperature drops by 3,5 degrees Fahrenheit. Okay, so it drops by 3,5 degrees Fahrenheit. Okay, so the plane is going up. Every 1,000 feet up, it goes down by 3,5 degrees. Now, if the temperature at sea level is 78 degrees Fahrenheit, okay, what would you expect the temperature to be at 10,000 feet, and that is in degrees Celsius? Okay, so every 1,000 feet that are going up in a plane, its temperature drops by 3.5. At sea level, the temperature is 78 degrees Fahrenheit, at 10,000 feet, what will the temperature be in degrees Celsius? And we're going to do this correct to 1 decimal place. Okay, so first they tell us, they give us a formula, and they say use the formula degrees Fahrenheit is 9/5 times degrees Celsius plus 32 degrees. Okay, so first of all, we've got to go and work out what the temperature is going to be at 10,000 feet. Now, for every 1,000, it drops by 3.5 degrees. So, how many 1,000s are there in 10,000? So, we've got to take this, divide it by 1,000, and that gives us a 10. Okay, so the temperature is going to drop by 10 times 3,5 degrees. Okay, so this gives you 35 degrees. Okay, now the temperature is dropping, it is going down. Okay, so what do we have to do? We've got to take, so let's just first write this down. At 10,000 feet, remember that's your little symbol for feet. Okay, the temperature is going to be 78 degrees Fahrenheit minus 35 degrees Fahrenheit. Okay, so now if we subtract those two, okay, so we subtract these, it's going to give us 43 degrees Fahrenheit. Okay, so now we've got to take that and we have to substitute that into our formula. Okay, so it's going to be 43 degrees, because that's where our Fahrenheit is on the left-hand side. That's going to be 9/5 times our degrees Celsius plus 32 degrees. Okay, so let's have a look. So the first thing we've got to do is we've got to take our plus 32 onto the other side. So we're going to say 43 degrees minus 32 degrees is equal to 9/5 times degrees Celsius. Okay, so we subtract this, it's going to give us 11 degrees. 9/5 times degrees Celsius. Okay, now we're going to do the same thing as what we did just now. We're going to multiply this by 5/9. Whatever you do on the right, you do on the left as well. Okay, so our final answer, let's do that on our calculator. Okay, so it's going to be 5/9, and we've got to multiply that by 11. Okay, so that gives us 6,1 recurring. Okay, so it's 6,111. Oops. Okay, degrees Celsius, and they want that correct to 1 decimal place, so it's going to be 6,1 degrees Celsius. Okay, now it's your turn to do some questions. Right, so your question is as follows. The winner of the coldest naturally occurring place on the Earth's surface competition is Antarctica. Now, do you know where Antarctica is? Okay, it's at the South Pole. Okay, and here the lowest recorded winter temperature was negative 80,6 degrees Celsius. The record low recorded in the Arctic, which of course is at the northern hemisphere by the North Pole, is negative 48,9 degrees Celsius. The first question is, what is the difference between these two temperatures? Okay, what's the difference between these two temperatures? Okay, right, and then your second question, I want you to take that answer and I want you to convert it to degrees Fahrenheit. And I want you to use this formula. Your degrees Celsius is 5/9 degrees Fahrenheit minus 32 degrees. Okay, so there's your values for the two difference. What's the difference? And convert it to Fahrenheit. Okay, so now we want the difference between these two. Now, these two numbers are both negative, so we can just take them and subtract them as though they are positives. Okay, so we're going to say 80,6 degrees minus 48.9 degrees, and that, do it on the calculator. Okay, so 80.6 minus 48.9. Okay, so our difference is 31.7. So this is 31.7 degrees. Okay, so that's the temperature that we have to convert. Okay, so this was Celsius. Okay, so in here we're going to put 31.7 degrees, and we want to calculate the degrees Fahrenheit. Okay, so now here, the first thing we have to do is we have to get rid of this 5/9. So what we're going to do is we're going to multiply by the inverse of this. Okay, now I can't quite fit it in there, so I'm going to put it at the end here. So I'm going to multiply by 9/5, and whatever I do on the left, I also do on the right. Okay, so we need to do this on our calculator and see what that gives us. So it's going to be 9/5, go sideways, and we're going to multiply that by 31.7. Okay, and let's see what that gives us, 57.06. Okay, so here we've got 57.06. So now we've multiplied by our 9/5, so these ones are going to cancel. Those cancels with that, and like that, they're all ones. Okay, so then here we've got degrees Fahrenheit minus 32 degrees. Then, to get rid of our minus 32 degrees, we're going to add 32 degrees. So on this side, we get 57.06. Okay, plus 32 degrees. And that's going to give us our degrees Fahrenheit. Okay, so our final answer, 57.06 plus 32 gives us 89.06. So it's 89.06 degrees. Did I tell you how many decimal places? I didn't, and it's a full answer, so you're going to leave it at 89.06 degrees. Thanks for joining me with this lesson.